Alright, welcome. In this video I'm going to show you how to calculate the height of a given volume that's inside of a provided frustum, I guess. So pretty straightforward. I didn't print the, actually I think I got it here. I can copy and paste it. Is the formula for the frustum, which is right here. So that's the formula for the frustum. The problem is if you don't have the height, say you have the volume and you don't know the height, you have the angles and you have the bottom radius, but you don't know the height. It's a lot of tricky algebra to try to figure that one out. In fact, I put it up there, and then you'd have to take this and solve for x. This is all equal to 2500 in this case, right? So x 2500 equals x divided by 3, and it's just basically the whole formula. But the problem is you get the square root here, so then you got to square everything. You got to take, this is divided by 3, so you got to multiply everything by 3 over 3, and then you could add those and then multiply, and it was too much algebra for me, and too much algebra for the algebra solver. So in this case we have a 2500 what we want to put into this frustum. Frustum has got a radius of 11 and a radius of 5. So you can calculate the area and put it into this formula. S1 and S2 is the surface area of the bottom, or actually surface 1 is the surface area of the top, and surface area 2 is the surface area of the bottom. And there you go, there's your 11-inch radius, or 11 unit radius, and then you put in the formula pi times radius, which is 11 b9 squared, and then you get that, and same thing with that one. And then the height is provided. These things that you can add. You could also have an open-ended frustum, and you would just need the angle. However, is provided, and in this case you'd want to calculate the area of the frustum, which we've done here, which is h divided by 3, which is C11. Yeah, 18 divided by 3, which is height divided by 3, times the area of R1 and the area of surface 2, and then plus the square root of area 1 times the area 2, and all that together will give you the area. So that's how you calculate the volume of a frustum. That's pretty easy to find. I didn't find anything on if you have a frustum and you need to get a certain quantity, a cubic or a volume quantity inside that frustum, how to calculate what the height would be. So that's what this is about. So you can calculate the angle, pretty straightforward. You got this here is 11 minus 5 would be 6, and then the height is 18, so arctangent of 6 divided by 18, there you go, degrees arctangent, b9 minus b5, so it leaves you 6 divided by 18, b11. Height, yeah. So that's how you get the angle, and you're going to need that. So to get this height, we need to do a few things first. So we're going to change this lower portion here to a cone, and then we're going to add those two cones together to get the total volume, and then we'll subtract. So actually there's some substitution trig, and then the last step it will be just subtract. So let's see. We have the lower cone, so we need to calculate what's this x1, and you already have kind of what you need here. So you have 11, which was the 6 that we had, right? 6 divided by 18. Well, 6 divided by 18 is the same ratio as 5 is to x. So let's see, if you flip that around, it's easier. So you'd have 18 divided by 6 is equal to 5, x divided by 5. That way the x is already on top. So 18 is to 6. 18, height is to the 6 as the height is to 5, right? And then you just multiply 18 times 5 is 50, 90 over 6, which is 15. So that's how you get 15. And that's what we got there. X1 is 15. So I showed the algebra steps there. It's a little hard to see on the screen, but that's how you do it. So 18, what should be actually, this should be, instead of 18, should be this number right here. Enter. And then that'll be it in case that changes. Now we have the area. We can calculate the area of that cone, which is done here, 1/3 of the pi times the radius squared times the height. So we have 1/3 pi b10 is the 5, which is basically the base of the radius, and then times the height, and then you get 392.699. That's the area of this bottom cone here. So you're going to take the area of that bottom cone and the 2500 you want, right? So C15 plus B8. C15 is the one we just did, plus B8, which is the 2500 that's here. Now you've got a cumulative total for those two cones, right? And then that's that number, 2892. And then cumulative cone height. So now we need to calculate this height. And this is, I think, where it gets a little bit of substitution. So let's go back. We're looking for 29.18. So let's see. So y is 29.18. So we're looking for this formula here, 1/3 pi, right? Here it is, 1/3 pi squared, pi times x squared, this one, times y, times which is the height, will give us the area that we're looking for, 2892. But right here we have two unknowns, x and y. So what we're going to do, since we have the angle also, if you have the angle in a side, you can calculate the other side. So what we're going to do is we're going to substitute. So we're going to say x divided by y. So x divided by y is the tangent of 18.43. And then what we'll do is we'll write that down, and then we'll solve for x. So x is equal to tangent of 18 times y. And then that means we can, since we solve for x is equal to that, we're going to replace x with tangent of 18.43 times y. So we take this same formula, and where we have y, we're going to place, where we have x, we're going to place the formula here, right? So we'll have just y as the unknown. So 1/3 pi times x, which is this, 1/3 pi times that bit we got right there, times y, squared, we're going to square it like it does here. So we replaced x and we squared it, times y, and then that's equal to the volume of the whole cone. We have 1/3 pi, and then I just took it all and kind of, so what I've done here is we just took a tangent of 18 and multiplied by y squared. I just squared them both and separated them. So we got tangent of 18.43 squared times y squared times y, because that's times y again over there. And then you end up with y cubed. If you move this, 3 goes to the other side, it's multiplied, pi goes to the bottom, tangent 18 goes to the squared, goes to the bottom. So, I mean, it's, yeah, divided by all that whole bit. So we end up with y cubed, which is what's left here, these y squared times y, is equal to 2892.69 times 3 divided by everything that was on top over here. And then you end up with y equals, and then you can do the cube root to get rid of the cubed. You just cube root it by, instead of, to move the cube root over here, you're going to just multiply the inverse of the cube root, which will give you the, I don't know, cube root, rooted cube. we get and anyways, you get 29. I didn't take many math classes, but you'll end up with 29.19, and that is the y that we're looking for right here. Should probably turn that to blue. Now that we have that, let's go back to the Excel. We have this and we have this, so x2, right? x2 is 29 minus the one we already know is 15. So it's already kind of taken this. I don't know, what do we got? 29, so that's the formula for that. And then this is C17, which is the x2 minus C14, which is 15, C15. So this minus the 15 will leave us with x3. Pretty straightforward. And then to close all your numbers, you would replace, I think I just did it, I just took the square root of 16, so the height, I just plugged that into the formula for the, looks like it didn't. What is that? So I'm looking for the radius now. So this radius here is 9.72, and I'm just trying to think how I did it. Square root of 16. Divided by 3, so the height divided by 3 times pi times 17. So honestly, I can't remember how and why I came up with this. C17 is the cumulative height. There's the volume. Oh, so it's just the square root. Why is it square root of that? Oh, because it's x squared. So it's 16, square root of 16. Square root of the volume. So it's a cone. So the cone is 1/3. So I didn't write it down. So I should probably just write it down. So x, so it would be 1 divided by 3 times pi times pi times h, which was 14, no, the total number, x2, 29.19 equals, that's the area, 2982. Enter. So let's see how that looks. And then if we solve for so pi times the x 5. Somehow are we just replacing this? Let me go back to the model 3. 1/3 pi times x squared times, so there's our height, x squared. So the x squared is the one we just solved for, right? Or no, we're still looking for this. We solved for the height, so 1/3 pi times the radius, which is unknown, squared. That's why it gets square rooted. So I show the steps here. And I don't know if that should be 29 equal. That should say equal, right? Backspace, equal. That's more like it. 1/3 pi times the radius squared times the height will equal the area of the full cone, the two cones here, 2982.69. So then you solve for x squared first. You'll end up just moving this over to 2892 times 3 divided by pi times divided by pi, open parentheses, times the height, close parenthesis. And then you end up square rooting both sides. You end up with x is equal to that. So that's where that formula came from. Let's Control C that and take it over to here. Control V. So I wouldn't need that. So that's where that came from. And so if we solve for x, we get 9.72, and that is the radius. That's the radius up here at the top of this, which I didn't really show, which is right there, right? So it's the top radius. Now we have the bottom radius and the top radius, and then we can input the numbers. So we have the height, which is of a frustum. We're going to plug it into the frustum. All right, so we have the radius of the top one, 9.73. No. Oh, it's the height divided by 3 times. And I put this stuff in separations because it's a little hard to keep track of the parentheses, right? So then I have is equal to radius 1, which is P5, pi times 5 squared. That's P1 and P2 got switched, right? So P1 is at the bottom, plus pi times the top radius squared. That'll give us the area 1 plus area 2 plus the square root of area 1 times area 2. And then I put the parentheses there, and I come up with this. I just inputted pi because that's what I could put into this calculator. Let's see, Control C, Tools, Calculator, Control V, Enter, and it doesn't come up. I think I had this problem before. So there's the 14, so it should be solvable. So what I did was I went to Excel. It's just too many parentheses for that program. And I went here, equals, Control V, Enter, and we end up with 2500, which is what we're looking for. The reason why it's a little off is because the pi is rounded and this angle is rounded, and that's it. So if this angle was extended way out and this angle and the pi was extended way out like I did here, you would end up with pretty close to the true number, and I'm in the wrong one. So, but it's the same. So we Control equals, Control V, Enter. There's a little error, a 7/1000ths, which is pretty small. But if you went here, it would get closer because in this calculation, I used everything that I needed there. So in here it says pi, so it's carrying probably to 12 decimal places in Excel. And there we go again, pi. So it's a little more accurate. If I actually, just so you know, equals pi, open parenthesis, close parenthesis, enter. If we take that, right click, go to format cells, number, carry that way out, see how far we can get. See, it starts to turn into zeros right around there. So it stops the calculation at 2, 4, 6, 8, 10, 12, like 15 decimal places. If you went here, and there you go. This one carries it out. If you were to copy and paste this into there, it'd get even more accurate. Excel's pretty good, but it stops at, you know, a trillionth of a pi. There you go. So that's how you calculate that. I think we did all the steps. We got to this, and B10, this is just bringing that same information down the surface area here. So right here I've got pi times this squared, and then right here I've got pi. So there's a surface area of the new radius, surface area of the same one, 5 squared times pi. And then this here, I just took those two, those three, so it just was closer to the C18 divided by 3, the height, which is here, right? Just using the surface and the surface, plugging it into the frustum calculator to calculate the frustum. That's how you calculate the height for a required volume inside of a constraints of a frustum that's an actual frustum that's provided to you. And you do it for, like I said, the first thing you do is check to see if the volume will fit. Just by calculating this and making sure that's smaller, and if it wasn't smaller, you'd be extending the sides of that frustum. That's how you do it. And I will never have to figure this out again because I'm going to post this video. Good luck in your career. Hope it helps you and make some money.